Now, we covered the differences between the two types of shaping machines, where we had the pillar type shaping machine, where on both shaping machines a head traversed across a workpiece carrying a tool, took a cut, then indexed itself along, took another cut, returned, indexed itself, took another cut, returned, indexed itself. So in a planing machine, or a shaping machine, sorry, the tool moves, or the table moved in relation to the tool, or in the travelling head machine, the tool moved in relation to the work. But shaping machines, it's a reciprocating ram carrying a tool does the work. Now, when Richard Roberts invented the planing machine, he invented a machine where he had a flat table, usually with T-slots in it, which could be traversed back and forward underneath the tool. And you can see there's a tool holder with a tool, with a clapper box, so that the tool didn't drag and blunt itself in the return strokes. In the planing machine, it consists of a bed with a very accurately machined surfaces with V locations to keep the table from crabbing. The table is held accurately in its travel, it can't crab. On the bed there is two side cheeks with machined faces which carry a cross rail. Now the cross rail has a screw arrangement which moves a saddle over the workpiece carrying the tool holder, a vertical slide with the tool holder on it. So the machineman can set the depths of cut with a handle there. He can also set the position of the slide in relation to the table. On this occasion it's quite near the table, or by using a screw. In this little machine it's only one central screw, but in huge heavy machines there's two screws, and you can lift the whole cross rail up or bring it down to suit whichever work is being operated upon. Now, in the planing machine, these side cheeks have to be held very tightly in alignment. They're bolted usually onto the side of the machine, onto the frame, and at the top you have a bridge which stops the rails splaying out or splaying in. They're set very accurately. And on the cross rail you have a very finely machined guides for the saddle to move on. Now, like the shaping machine, you can set the limit of the stroke. Only in the shaping machine we set the distance the ram travelled, but in this machine we set the distance the table can travel. Now this is a hand operated planing machine, a very small machine. The original machine built by Richard Roberts was also hand operated, and it was a bigger machine than this, so it must have been very hard work for the operator. Now as times rolled on, they made bigger machines which were driven by external sources. Usually you had a belt arrangement with 3 pulley wheels, and by engaging one set of gearing in one wheel, the table could be brought out on the return stroke, and then the belts moved over and brought the table in on the cutting stroke. A set of stops which were fitted to the side of the table engaged the mechanism which threw the belt back over to give the return stroke. Now, should the operator have wished to stop the machine, he had a lever which he could engage, and it threw the drive belt into a neutral position. Pretty sort of, by our standards today, an inefficient way of working. But in their days, marvellous things were done with these belt-driven machines. But as times rolled on, they needed to get stronger sorts of machines, more efficient machines. And one thing they used to do, the Germans, they brought out magnetic clutches. One was called the Vulcan clutch, which the belts were running a set speed all the time, and the clutches were engaged by the tappets hit a wee electrical contact which moved one clutch in, one clutch out. Then along came some clever folk in England, Lancashire Dynamo Company, and they invented a system called the Ward-Leonard motor control, in which you had a motor generator running all the time. And the motor generator fed DC power into the windings of the drive motor. So you could reverse the electric motor, stop, very gently bring it to a rest, and reverse for the return cut or the return feed or the cut, back and forward, without being destructive to the motor. In the 1950s, Associated Electrical Industry Company brought out another system called the closed loop system, where they used AC motors. Both these systems were very efficient drives for the more powerful machines on the go. In America, the Niles Bement Pond Company, they had compressed air driven clutches in their big planing machines. But by this stage we're into very powerful and modern machines. Now, the Achilles heel of a planing machine is the amount of power it takes to move the table back and forward. And in a huge machine, this becomes quite a problem with the cost of electricity. So by and large nowadays, what happens is the planing machines had the tables slowed down, so they went quite slow, and on the cross rail was fitted a milling head. So you had things called plano millers. So one could do the same sort of work, take broader cuts with a powerful milling cutter, and achieve almost the same results. Now, the planing machine gave the advantage it could give a very fine finish to its work. So that's how it won for so long. Generally speaking, a planing machine did large work. A shaping machine was used for smaller work. Usually you found a shaping machine in a tool room location. A planing machine usually was found in a production system out in the main body of the engineering work, handling heavy forgings, castings and heavy bar stock. Now, this machine is unusual in respect of the smallness of it. It's a baby sort of machine in a way, it's tiny. It's a 6-inch cross. You can machine actually almost 7 inches, 6.5 inches across the way, 6.5 inches vertical. So if you visualise a cube shape, 6.5 inches one way, 6.5 inches the other way, and a 20-inch stroke. But that is very small. This machine was built by a firm called Tom Senior and Company in Liversedge in Yorkshire. And Tom Senior made these machines for very small manufacturing concerns where they possibly didn't have power to their machines, or for home craftsmen's use. I purchased this machine about 15 years ago from a chap. I don't think he was ever going to use it again. The man wasn't really well enough to use it. It was becoming a little neglected. It's quite a handy machine. Now the workpiece I have on it, I'm machining, taking a cut 0.850 deep. I've marked the line where I'm cutting down to. So at the moment I have been roughing the piece of work out. So we'll set the tool over and we'll start and let you see it taking a cut.